In this lesson, we're going to solve radical equations. Here I have x minus 4 to the 2/3 power minus 9 equals 16. So, though this isn't radical, it could be written as radical. It is a rational statement, or it has a rational exponent rather. And the easiest way to solve this is to solve it as a rational. So what I'm going to do is isolate the unit that's squared by adding 9 to both sides. And that leaves me with x minus 4 to the 2/3 power, and then 16 plus 9 is going to give me 25. Okay, now what I need to do is I need to get rid of this 2/3 power. And the best way to do that is to put this to the power of 3/2, or in other words, the reciprocal. But of course, what you do to one side, you must do to the other. The reason I do that is because when I multiply these, I'm going to get 6 over 6, which is just 1. So it would be x minus 4 to the 6 over 6 power, which is equal to 25 to the 3/2 power. So I really don't need to write the 6 over 6. They essentially just cancel out, since that's just 1. Now, I'm going to simplify this 25 to the 3/2 power. So I'm going to have x minus 4 equals, so remember this can be rewritten as 25 to the 1/2 power cubed, or in other words, the square root of 25, which is 5 cubed, and then here's my x minus 4. I really don't need the parentheses anymore. And so that's going to give me 5 cubed is going to give me 125. So I'll have x minus 4 equals 125. I add 4 to both sides, here and here, and thus I have x is equal to 129. And that is my solution. I box that guy in. Okay, the next one, I have an actual radical, and so I'm going to handle this like we have in the past with radicals. I'm going to square both sides. So I'm going to start off and I'm going to square this as well as this. This is going to leave me with x minus 6 because the square root and the square cancel out. And then x minus 8. Okay, remember, exponents do not distribute. This is not going to be x squared minus 8 squared. It's going to be x minus 8 times x minus 8, or we could just use a special product of a squared minus 2ab, or 16x, plus b squared, which is 64. Okay. Now I'm going to add 6 to both sides and subtract x. Basically, I'm going to set this equal to 0. So I'm going to be left with x squared. Make that look like an x. X squared minus 17x plus 70 equals 0. Okay, now all I have to do is solve this quadratic. So this is going to factor to x actually not plus, minus x minus 7 and x minus 10 equals 0. And then I'll say, well, then x is equal to, and then 7 and 10. But wait, we don't stop there. Because we have a square root here, a radical, we need to actually test our solutions. We really do need to substitute these in and see if they work. So that's going to be the square root of 7 minus 6, which should equal 7 minus 8. Okay, well, 7 minus 6 is 1, so square root of 1, and then this is going to equal negative 1. Well, square root of 1 is 1, but 1 does not equal negative 1. 7 is not a real solution. 7 is what we call an extraneous solution. Now we'll test out 10. We'll substitute 10 into both. Okay, so square root of 10 minus 6 equals 10 minus 8. 10 minus 6 is 4, so the square root of 4, and then 10 minus 8 is 2. Square root of 4 is 2, and 2 equals 2. That checks out. So 10 is our only real solution. So the way I'm going to write this is like so. I'm just going to say x equals 10, and then I'm going to say extraneous OUS. Extraneous solution is going to be x equals 7. And then I'm going to box these in. Okay. Sometimes I'll ask for the solution, so I just want 10. Sometimes I want to list out the extraneous solutions as well. You'll just have to read the directions as per each problem. In our third example, we have a radical on both sides of the equation. So here's how we handle that. We'll start off by getting rid of the radicals, or trying to, by squaring both sides. So I'll have the square root of x plus 6 minus 2 squared equals x, well, the square root of x minus 2 squared. Okay, so again, the 2 does not distribute, so we're going to use our special product property, and this is going to be the square root of x plus 6, and see that's our a squared, minus 2ab, so 2a is this value, so the square root of x plus 6, and then b is just going to be 2, plus, or rather equal, oh no, plus, I'm sorry, plus 4 equals x minus 2. Alright, so now I'm going to simplify the left side. So that's just going to give me x plus 6, and then I'll have minus 2 and 2 gives me 4. Square root of x plus 6 plus 4 equals x minus 2. Now I'm going to subtract x from both sides, as well as subtract 6 and 4, because what I want to do here is I want to isolate our radical. We want to isolate this radical here so we can solve it. So then I'm going to rewrite this. That leaves me with negative 4 square root of x plus 6 equals, the x's cancel out, leaving us with just negative 12. Now I'll divide both sides by negative 4. And I'll be left with the square root of x plus 6, which equals 3. Now that I've isolated the square root, I'll go ahead and square both sides once again. So one more time, we're squaring. That's going to give me x plus 6, which equals 3 squared, or 9. Now I just subtract 6 on both sides, and I'll be left with x equals 3. So I'm set with just a single solution here, but I still want to check to make sure if it is in fact a solution. So I'll substitute this back in to our original equation. So it'll be the square root of 3 minus 6 minus 2 equals the square root of x minus 2. Or rather 3 plus 6. So that'll be the square root of 9 minus 2. And since we're substituting in 3, I should substitute 3 on the other side as well. And that's just going to give me the square root of 1. So now I'm left with 3 minus 2, which equals the 1, and 1 equals 1. So that checks out. So it is in fact x equals 3 is our solution. So that's solving radical equations. Till next time, I'll see you on the flip side.